Hello friends, welcome back and a very happy Teachers Day. So today we have this another question from physics. It is question number 21 on page 196 from H.C. Verma. So it is a very simple looking question, but yes, a lot of students do mistake in such type of questions, and there is a lot of probability that you will learn something new in this question. So let us see the question. So you can open the book and read the question on yourself. So this is a rough inclined plane of inclination theta. There is a mass m and its edge size is a. So there is a cube. This is the cube of edge size a. Okay. So this is a cube, and it is coming down with uniform speed. We need to find the torque of normal reaction acting on the block about its center. Yeah. So this is the question. Let us see how to solve it. So first of all, let us make the FBD. Whatever the position or orientation of object is, we never have to change that. Okay. So this is the orientation of object. Mg, the property of Mg is it acts downward. This we have already discussed in our previous videos. You can check the videos if you do not know about it. So whatever be the orientation of object, it is always downward. First of all. Second thing is, I have already told you that normal reaction acts perpendicular to the point of contact. But where exactly, that we do not know. Yeah. Generally we take normal reaction to be acting like this, but in this case it may not be so. Let us see why. Second thing, it is a rough plane, so we need to put some friction here. Yes. Now you can see if it is moving with uniform speed, right? If I put normal reaction here, mg here, both of them will have zero torque about the center because its distance from the center is zero, right? Because torque is r cross f. If this is the only one which is creating torque, we need to change the position of normal reaction so that normal reaction can balance the torque of friction. That means normal reaction will act, some distance ahead, say x from the center. Now normal reaction is already acting perpendicular to the point of contact that we have already studied, but it doesn't passes through the center. It passes the distance x from the center. Yeah. So let us resolve this mg. This is mg sin theta and this is mg cos theta. This we have already studied because if this is theta, 90 minus theta, this again becomes theta. So this is mg cos theta, this is mg sin theta. Now another thing that we need to note here is, it is coming with uniform speed, that means acceleration is 0. If acceleration is 0, we can say friction is equal to this. So we can say F is equal to mg sin theta. Because see, it was sliding. Yeah. So it was sliding. So you can say that it is moving, so friction must be maximum. You can say that, but mu is not given in the question, right? So we have to consider friction in some other terms. And what I have done is friction is equal to mg sin theta because acceleration is 0. This is first thing, right? Now let us balance the torque about the center. Torque of mg sin theta and mg cos theta is 0 because they are acting at the center. Now the torque of normal reaction is how much? N into x, force into perpendicular distance, and the torque of friction is F into a by 2, force into distance a by 2. This is a by 2 because complete distance is a. Both will be equal because it is not toppling or it is not rotating, right? So it is just sliding with uniform speed. So these are equal, and how much is n? N is equal to mg cos theta. We were asked in the question of about only torque, so we can say torque is this, and we already know this. So that means torque is a by 2 into mg sin theta. This is the answer to the question, right? So this is the answer to the question, the torque. But we can very well be asked about this distance x, the distance at which normal reaction acts. Yeah. So we need to tell this also. Then we can say, we can put the value of n here. We can have mg cos theta into x is equal to mg sin theta into a by 2. From here we have x as mg gets cancelled, a by 2 into tan theta, right? So this is the distance at which normal reaction will act away from the center, and how much is the torque of normal reaction? This is the answer. So this is what we need to understand. And if you imagine the question, see, it is sliding down, right? Now friction is applying some torque. That means more pressure will come on this side, right? So normal reaction doesn't pass from the center. more pressure is coming here, so normal action will be more here. Yeah, if I press the some surface more from one side, normal action will be more from that side only. That means normal action will act this way, the friction stroke is this way. Yeah, that is why normal reaction has shifted. Normal action is like, it is its position is self-adjusting, just like friction that we studied in the chapter. Friction is a self-adjusting force on its own, completely. So normal reaction's position is also self-adjusting. So this is all we need to know about this question. It looks very simple, but such type of questions have been asked in JEE and very important for NEET and IIT JEE. And this is what we need to learn from this question, that normal reactions position can be anywhere, as per the need of the problem, as per the situation. So you can imagine it practically, or you can do like this. Yeah. So that's it for today. I hope you have understood the question. So if you have any doubts, you can write it in the comments and share this video with all your friends. We'll meet in the next class with another amazing video. Till then, keep practicing on.